day. Welcome to another opportunity to learn from my channel. Today we want to discuss complex number based on this question we have on the board. The question says, express this in standard form, and these are the options. With these options, it has signaled to you that the standard form they mean is not your normal a.0 times 10 raised to the power of n, where a and n is this integer, while this number, this is a number, this is a power, this is a number. This is a simple definition of standard form. But with the option they gave, it means you are not talking about this type of packaging of answer. So that means I'm to solve this to see which of these options are correct. It is important to note that there are different ways a particular complex number can be expressed. You can express it in polar form. You can also express it in Euler form. For you to express it in polar form, you say r bracket cos theta plus I sin theta, where the theta is the arguments. It could be the principal argument, that is the first value of theta. It could be the second argument, third argument, fourth argument, depending on the options given to you. You can also put it in Euler form, which is r exponential theta I, where the theta can be the what? First argument, that is principal argument. Principal argument is what we call the first argument. The theta p can also be called the second argument, the third argument, the fourth argument, and so on and so forth. That means these are two ways you can express your words complex number, as a polar form and as a Euler form. Now we are given this. Ordinarily, this r is meant to be this, and this r must have a relationship with theta pi. Take for instance, if you are asked to get, let's say you are asked to get, find the polar Euler form of z equals to 1 plus what? I. Polar form of z equal to 1 plus I. And find the polar form, find the Euler form. So we want to put this into these two ways. If you are asked to do that, say that your r will be equal to square root of what? 1 plus, what is coefficient of I? 1. That is square root of what? 2. So square root of 1 square plus 1 square. Square root of this 1 square plus square root of this 1 square equal to 1 square is 1, 1 square is 1, 1 plus 1, 2, square root of 2. That is the r, value of r. The r is called the modulus of a complex number. The r is called the modulus of a complex number. So what you need to do now is to get your theta p. And theta p, if it falls at the first quadrant, if this falls at the first quadrant, I will say that my ref theta will be equal to tan inverse of what? Tan inverse of y over x. Then my principal argument will be equal to plus ref theta. Plus ref theta. But if it falls in the second quadrant, this is already my ref theta. Ref theta is reference theta equals to tan inverse of modulus of y over s. In 4 here, say that your PA will be equal to 120 minus ref theta. If you fall here, say that your PA is equal to theta is equal to ref theta equals to ref theta minus 180 degree. Then if you fall here, say that PA equal to minus ref theta. So first quadrant, second quadrant, third quadrant, and what? Fourth quadrant. Third quadrant is ref theta minus 180. Why here is minus ref theta? That is for fourth quadrant. Now let's check. Here is positive x. Complex number is noted with x plus yi. So this is my x, and this is my y, and this is my I. So y is approximately 1. Y equal to plus 1, x equal to plus 1. Then I will say this is 1, this is my y positive, and this is my x positive. This is positive x, this is positive y. You will see it will fall in first quadrant. That means I should get the tan inverse of what? 1 over 1. I will now say, since it's that way, my ref theta will be equal to tan inverse of what? What is my y? 1. What is my s? 1. 1 over 1 is equal to 1. Tan inverse of 1 is equal to 45 degrees. Since ref theta is 45 degrees, I will say, let me put it in radian. 180 degrees equals to pi radian. That is the relationship between degrees and radian. 45 degrees will be equal to cross multiply. Pi will be giving me 45 over 180 pi. This is 1, this is 4. That is pi over 4. That means 45 degrees is equals to pi over 4 radian. Then what is my principal argument? In the first one, the principal argument is equal to plus ref theta. And plus ref theta, what is our ref theta? Pi over 4. Plus ref theta means the pi will be positive. The pi over 4 will be positive. With that, I will come and say that in polar form, my arrow is what? Root 2. My theta is what? Cos what? Pi over what? 4. That is the value of theta p in radian. And this, what I just got, is the first value of the theta. That is what I got. That is the meaning of PA. PA means the first value of theta. That is principal argument. Then plus I sine what? Pi over 4. That is in polar form. In Euler form, I will write R first. Root 2 exponential pi over 4 I. That means this pi over root 2 has a link with pi over 4. They are related. You can't have more than root 2 here if you are talking about pi over 4. If it is not pi over 4 that you have here, it must be that either you have pi over 4 or you have pi over 4 plus 2 pi k. Where k, when k is 0. When k is 0, you have pi over 4. When k is 1, you will be having it to be pi over 4 plus 2k. Plus 2k over 1. That will be giving you 4 pi plus 8 pi. Pi plus 8 pi will be giving you 9 pi over 4. That means you have gotten the second argument. So if here is not like this, it can also be root 2 exponential 9 over 4 what? pi I over raised to the power 9 pi over 4i. If it is not like this is with respect to principal argument, that is the first value of theta. Then this is with respect to what? Second argument, that is the second value of theta. If it is not like this, you can put when k is 2 and get it and put as well when k is 3. So the answer for your theta must fall in the range of this value. When k is 0, when k is 1, when k is 2. Outside that, it means it's not correct. Now, when you have something like this, pi over 3 has no link with 4 plus 6i, because ordinarily what should be beside this exponential is a value called modulus, and modulus simply mean a result you will get that will not have I. A result you will get when you get square root of this square plus 1 square. There is no way you will get square root of this and I will still be there. Because of that, it will set your mind that this is not the modulus of this. And because of that, see what you do. Because of that, see what you do. You say this means 4 plus 6i. Now put this in polar form. It will give you bracket cos pi over 3 plus I sine pi over 3. That means pi over 3 is what? So I have brought down this and put it like this in polar form. Polar form of this. Why this is Euler form of it. So polar form use cos and sine. Why Euler form use e exponential. Now pi means 180. 180 over 3 is 60, right? Cos 60 is equal to sine 30, that is 1 over 2. Cos 60 is 1 over 2, and we got 60 by saying pi is 180. 180 over 3 is 60, cos 60 is 1 over 2, plus 180 over 3 is 60, sin 60 is equal to what? Sin 60 equal to cos 30, that is root 3 over 2, or bracket 4 plus 6i. Now expand it. 4 times 1 over 2 will give me 2. 4 times this will give me I root 3 over 2. This times this will give me 3i. 6 times 1 over 2 will give me 3i. 6i times this. I times I will give me what? Please know that I times I is equal to minus 1. How did I get it? In complex number, I means square root of minus 1. Another I means square root of minus 1. Then from rule of such, square root of two same number. Multiplying two same number under square root is same thing as that same number. So it means that I times I will give me minus 1. 6 times this will give me what? 6 times this will give me 3 sub 3. Okay? Because 6 over 2 will give me 3. Then that 3 times root 3 will give me sub 3. Okay? So what I will do now is I will say let me collect like terms. This one minus 1 times 3 root 3 will give me minus 3 root 3. I will have it final to be minus 3 root 3. So what I will now do is I will say how did they package it? They package it, the one without I will come first, while the one with I will follow. Okay, this and this do not have I will say 2 minus 3 sub 3. This one have I, plus I'll bring out the I and say this will be 3 plus root 3 over 2. I'll check. It did not, we did not see it. We cross check what we did. 4 times this 2, 4 times this will give me what? 4 divided by 2 is 2. So what we'll be having is 2 root 3, not root 3 over 2. 2 root 3. So I will now say, when I bring that I in common, I will say 3 plus what? 2 root 3. I will check, is it packaged that way? Yes. Yes. So option B has it. 2 minus 3 root 3 plus. Remember, this thing you are saying here is the same thing as you saying 2 root 3 plus 3i. Is the same thing. The reason is because addition of numbers are commutative. If you say 3 plus 2 root 3, it's the same thing as you saying 2 root 3 plus 3. Please, you can see options we are given in this question for you to see how they want you to package it, so that you pick your answer based on the way they want the packaging to be done. So the answer is option B. Option B. That is 2 minus 3 root 3 plus 2 root 3 plus 3, or bracket what? I. Okay, so that is how to solve this problem. Thank you for watching today's video.